Good morning all. In this video, today I am going to explain about the content beyond syllabus. What is this content beyond syllabus? It is nothing but what and all we have learned in this module. The applications will be discussed, which is not there in the syllabus, but you must be knowing what exactly we are learning and where exactly the applications are there. So this will be discussed in detail, like various fields of engineering and other fields, how this complex functions or analytic functions or harmonic functions, all these things, the CR equations, where exactly this will be used. Some of the applications are the triangular grid generation, potential field path planning, robotics applications, and complete path planning algorithm. These are the few applications which I will be discussing in this video. So coming to the first part, that is triangular grid generation. When we do the construction of the buildings, the very huge buildings where the boundaries will be very smooth and we need to have various types of grid. See, it was shown that the CR equations can be used in order to generate the triangular grids around an object. In order to make the method more practical, it is necessary to develop a technique by which we can control the quality of grid. It appears that this can be done by introducing the source terms in the Cauchy-Riemann equations, which we have studied already in the previous videos, both in Cartesian as well as in the polar form. Look at the triangular grid generation. Some of the images I have posted here. This is the O grid generated by the CR equations. And here is the grid in the solution space. This O grid generation, it is generated by the CR equations. Similarly, we also have various other types, that is C grid. C grid, and you can see here O shaped. The same way we can find C. Around this the grid will be generated. So that is C grid generation. So for this smooth surface we can see. So for that only we will be using this CR equations, and many more applications we can find. Here is one of the example I could quote, that is Yas Viceroy Hotel Abu Dhabi, UAE. You can observe here the triangular grid which has been used over here. So how smoothly it has appeared, that we can observe in this picture. Next, another one is in China, Shenzhen Base Port Center from China. Here also we can observe many are using this triangular grid generation, and here also the CR equations will be used in order to generate the triangular grid. You can observe O grid, C grid, etc. Everything will be used in this construction of the building. So coming to the harmonic property, some of the curves I have explained 1 by z square, and so that is about the CR equations where it is used. Next, when it comes to harmonic functions, the harmonic functions are solutions to Laplace's equations. Such functions can be used to advantage for potential field path planning because they do not exhibit spurious local minima. The harmonic functions are shown here to have a number of properties that are essential to robotics applications. And the paths which are derived from the harmonic functions are generally very smooth. So the harmonic functions also offer a complete path planning algorithm. That is, the robotic one or path will be derived from the harmonic functions, which will be very smooth. The generally smooth one we can obtain the paths. Where and all it will be used? Supposing if you wanted to find out the path of a robot, this harmonic functions which generates the smooth path, we can easily find out what and all the ways a robot can move. That is the application. Here we can see the potential surface, or here it is a potential contour when y is equal to 1 and when y is equal to 5. And here is the potential surface for y is equal to 1, that is for the first one, this is y is 1, and when y is 5, that is the height is increased, this is how it looks like. So this is the robotic path which is generated by using the harmonic function. We can observe in the blue line, these are all the paths, various paths which we can see here. This is different paths we can see which has been generated. Actually the arrows also you can see how it has generated. Next, this is one of the curve which we use frequently. This is the problem which we will be using here, that is e power z as e power x of cos y plus I sin y. So this is the function which I have showed here, a familiar one, exponential function. This is 1 upon z square. This is also one of the familiar function which we are using here. Thank you. So here we have discussed some of the applications in the engineering, that is robotic path generation or a complete path generation. Supposing if you are taking a small robot and how to generate the path, what and all the movements it can be generated by using the harmonic property. We'll come up with some more applications in the next video. Thank you.